actually getting into some of the meat of what I want to talk about today. Viable air monitoring. In particular, finding out the bacterial load or the yeast and mold contamination that's actually in the rooms that you're preparing food or bottling juice or bottling water. Any of these kind of labs that you may have, you want to know what the contamination levels in those rooms are. And it's important because, quite frankly, that air is touching your food as well. A lot of times, it may look like it's indirect, but in reality, it actually is a very direct process where it's not just a food or a knife or a packaged material that's touching your food, but it's the air around these preparation areas that are very important to consider. So we're going to talk about what it is, go through a couple of different methods, why you should be doing it, why you might want to integrate this into your existing HACCP plans, and how we can do this. We're also going to be talking about not just the air that we're breathing here, but compressed air. Because compressed air is something that is prevalent in food labs, in labs around the world for any number of things. But it's not considered as part of the environment because, well, it's in a tank somewhere else, right? But still, that air is being released into the rooms, and if that air is contaminated, that can be a problem for your food as well. So, viable air monitoring, airborne contamination, detecting and quantifying organisms in the air. Very, very simple. Sources of the microcontamination, food, water, packaging, any of these number of things. One big thing I left out. You all know what it is, right? People. It's always the people. The people are the dirtiest thing in your clean rooms. The dirtiest thing in your preparation areas. They're the ones that are doing this. So anybody that's actively moving around are shedding colony-forming units. Like I am shedding colony-forming units right now in sweat. Represented here by our friend Pigpen, which is a very exaggerated example of the operators that are in your rooms and preparing your food and cutting your food and packaging your food. These people are the ones that are shedding a lot of the contamination or the possible sources of contamination that might be your products. So we want to know if they are actually the ones that are contaminating the food, how do we solve it? So I know that, for example, Robin and Dr. White yesterday were talking about a number of things like risk. Risk was a big term that was used yesterday, and bringing that into here, how risky is it, or how much risk do these operators bring to the product itself? Okay? So, let's go over a couple of methods. As I mentioned before, the first one that's been used literally forever, the idea of putting an agar plate onto a surface and put it maybe on your food prep area. Something like that. You just leave it there, and it sits there for anywhere from 15 minutes, I've heard, all the way up to 4 hours. What that is doing is, yes, it is sampling air, but you really don't have an idea of how much air that's sampling. So that while I certainly agree with the theory of it, there's possibly a better way to do it, and that's one of the things that we're going to discuss today. There's active sampling, sieve impaction. This is one of the units that we brought, and it's sitting back there. You might think it looks like R2-D2, which it really does. The idea here is, instead of hoping that the contamination that's in your air settles onto a plate that's on a table somewhere and isn't blown away by somebody walking past, or a fan that's going, or something to that effect. You're hoping that the contamination that's in the air is settling on your plate. Instead of that, let's vacuum air and let's impact it onto an agar surface. That way we're sure that the microorganisms themselves are hitting the agar surface, they're sticking in the agar surface, and then you can grow them afterwards. That it's not a lethal impaction. That's a very important thing, and that's part of the technology that I'm not going to get that deep into, but that's one of the things that kind of attracted me to this area, is the technology and how we can use the technology and the advancements that we have to make our lives better, make our lives easier, make the food safer in the end. Because that's all obviously what